Okay guys, hopefully this will be the last part for type of matrix. Okay, in this video we are going to talk about on how to sum, how to subtract, and how to multiply matrix. Okay, for matrix division we have to talk in other part. Okay, now to sum a matrix. Okay, to sum a matrix, by right you should the order of the two matrix should be in the same order. So if you want to sum between A and B, first it should be in the same order, 2 by 2 with 2 by 2. Okay, if it is for this one 2 by 3 and 2 by 2, it is actually undefined because we cannot sum it. Because in order for us to sum between two matrix, we will sum it by element. So A11 will plus with A11, A12 will plus with A12. So that's why they need to be in the same order. So if they are in a different order, so we cannot really sum this one because it don't really have its pair, right? Okay, now that is for summation. Next, let's look at the subtraction. The same. For subtraction, it is the same. They need to be in the same order. Okay, so if we look at this, for example, we can subtract between A and B because they are having the same order of 2 by 3. As for C, we cannot actually conduct the operation of subtraction with A and B to C. As you can see here, B and A, yes, we can subtract B to A or A to B. As for B to C, where it cannot be done because they are having the different order. So let's look a bit on properties. Okay, A plus B is the same as B plus A. B plus C then plus with A is the same as A plus B then plus with C. So this is actually a zero matrix, right? Indicate by 0. So any matrix sum with a zero matrix will give back the A. Okay, obviously. And next, if A is being summed to the negative A, in other words, it becomes A minus A, right? So you will get zero matrix. Okay, that is a little bit of properties. Now let's look at a multiplication. In multiplication of matrix, we have two kinds of multiplication. The first one is known as scalar multiplication. Okay, scalar multiplication, and the second one is known as matrix multiplication. Alright, where is it? This one, matrix multiplication. So for scalar multiplication, it is just simply a whole number, any value, actually any number, any real value, multiply with a matrix, right? It is denoted by alpha A, where alpha here is actually the scalar. Okay, for example here, given this matrix, what is negative 2 times A? So this is a scalar matrix. This is actually a scalar multiplication, sorry, where you times numbers, just a real number, with any matrix, right? So how to multiply it? Simply multiply each element with negative 2. So negative 2 times 3 you will get negative 6. Negative 2 times negative 2 you get 4. Negative 2 times 0 is still 0, and so on and so forth until the end. So next, find negative A. This is actually indicate negative matrix, right? But it is actually also can be considered as scalar multiplication because we can look at it as negative 1 times A, right? So just simply as we did in the first one, just multiply it and you'll get the answer for scalar multiplication. Scalar multiplication is quite easy. Now this is the properties. Okay, so A plus B and then times with the scalar is the same as A times with the scalar, and B times with the scalar, and then sum them together. So A scalar plus with B, right, and then multiply with A is the same as scalar times with A plus with oh no, actually not B, sorry. Scalar A, this is the first scalar, plus with the second scalar, and then multiply to A is the same as scalar A, the scalar, the first scalar times A plus with the second scalar times A. Now for this one you have two different scalar, two different value. For this one, A times B, scalar A times scalar B, and then you times with the matrix, the same as you times the first scalar with the second scalar times the matrix. Okay, now identity times with the matrix, you will get the matrix itself, 0 matrix times the matrix, you will get a 0 matrix. Okay, that is for scalar multiplication. Now let's look at matrix multiplication. For this one, before we can conduct any multiplication, right, the first thing that you need to, there are one thing that you need to be clear with. I have already mentioned this in advance regarding this. Okay, just look at this. This is regarding the order. Okay, two matrix can only be multiplied if they are having the same the same row and column. I mean, it is not the same row and column, sorry, if they are having this kind of form. So if the first row, if the first matrix is 2 by 2 and the second matrix is 2 by 3, if you look at the value of the matrices in the middle, you have 2 and 2 here, the same value, then this two matrix is actually can be multiplied, and you will the matrix that you will obtain by multiplying these two matrix is 2 by 3. Okay, if let's say 2 by 3 multiplied with another 2 by 3, then this one is an example of the matrix that can't be multiplied, right? Because if you look at this value, they are not the same. So the idea is to make sure that your matrix, your two matrices can be multiplied is by checking on this, right? Like this, should be the same, and you can expect that the answer later should be in the form, the order later should be in the form of 2 by 3 for this example. I hope you understand what I mean. Now let's try to look at an example. Okay, given A, B, C and D. For this one is 3 by 2, this one is 2 by 3, this one is 2 by 2, and this one is 2 by 2. Find the product, find each product, right, is defined A, B. So A, let's first check on the order. So for A, it is 2 by 3, right? So it is actually 2 by 3, right, multiplied with B. B is no, it's 3 by 2, sorry, A is 3 by 2. Let me change it. A is 3 by 2, and for B it is 2 by 3. 2 by 3. So we check it can be multiplied, possible to be multiplied because it has the same value here, and the result, right, later we can expect it to be in the form in the order of 3 by 3, right? 3 by 3. So 3 by 3. So let's because we know that it can be multiplied, let's try to multiply it. Okay, so we have for the way to multiply, to conduct multiplication, matrix multiplication, is to multiply the row, each row, right, to multiply this row, each row with each column, one by one. So first, right, we do 4 times 2 plus with 2 times -1, hence you get 6. Okay, next we do 6 times 2 plus with 1 times -1, hence you get 11. After that, we'll go 3 times 2 plus with 5 times negative 1, and that will give you 1. So that operation alone will give you, okay, again, all of this operation will give you the first column, okay, the first column only. So that just now the operation that we did will give you the first column. Now we do the same multiplication with the second column to get the second columns. So 4 times 3 plus with 2 times negative 2, you'll get 8. 6 times 3 plus with 1 times negative 2, you should get 16. 3 times 3 plus with 5 times negative 2, you should get negative 1. So, and that will give us the second column, right? The second column. And for the last column, the operation is the same. Multiply each row with the same column to get these columns. This is how you multiply. And as we checked before, 3 by 2 times with 2 by 3, you'll get 3 by 3, right? Okay, as for the next one, let's check B, A. So B times A. So we have 2 times 3, B, which is the B, multiplied with A, which is 3 times 2. So first we'll check it is actually can be multiplied because they have the same value here, and the result later will be in the form of 2 by 2. 2 by 2. So as you can see here, this is the answer. Sorry, for BA, this is the answer, 2 times 2. Now let's check on CD. For CD, C and D, it is 2 times 2 with 2 times 2. Alright, so just basically 2 times 2 with 2 times 2. So it is the same, and the answer the expected order will be 2 times 2. So there you have it, 2 times 2. Okay. And lastly, D and C. So D and C, so basically this is just the other way around, so you should also get 2 times 2. So that is how you multiply using metric multiplication. Alright, you need to multiply each row with the same column and proceed the same way for the next column and the next and the other columns. Right? So this is the properties of metric multiplication. Okay, just like what we have, the properties that we have in just a normal kind of multiplication. So A times with B and C, B plus C in the bracket, and so B plus C and times with A, the same as A times B plus A plus times C. It's known as a distributive law. We distribute A within B and C, right? And the same goes for this one. It is a distributive law. Associative law, where we B plus times C is and then times A is equal to A times B and then times C. Okay, and this can be actually applied for scalar multiplication. If you multiply two metric and then multiply with a scalar value, or you multiply A with a scalar value and then multiply with another metric, it will still give you the same value. Okay, so this is the exercise. You can try to do it later. Alright, so the next part will be determinant. Okay, so thank you.